Alright, today we have the application problems for polynomials, and these are probably going to be a little bit more difficult than what you did in Algebra 2, but same concept, and you've got to know some simple formulas like the volume of a box, the volume of a cylinder area, of a triangle. Like, you just have to know a bunch of those formulas from geometry, so be sure and beware that anything that you see in the notes in the homework could show up on a test or a quiz. In this case, the test, since we've already taken the quiz. All right, so an open box is made from a 10 by 12 piece of cardboard. The best thing to do is to draw a picture. So here's a 12 by 10-inch piece of cardboard. It says we're going to cut X inch squares from each corner and fold up the sides to make a box. So I would draw that in there. Draw little X length boxes. So what that ends up being is it folds it up. So here, if I were to draw the box, so now that's what the box looks like. Okay, so it's folded up. It does not have a top. It has a bottom. It has 4 sides. So writing a function, what would happen is originally the box was, or the piece of paper, cardboard, was 10 by 12, but we folded it up. So this was length X and this was length X. Therefore, from here to here is going to be 12 minus each of those X's. And from here to here started out being 10, but we subtracted 2 X's. And so now we have a new length and the width. So we have, let's call this our 10 minus 2x. Then we have our 12 minus 2x. But we also now gained a height, which was x. That's what we folded up each side by. So write a function giving the volume of the box in terms of x. So volume in terms of x, that's how you would write that, function notation. And we have an x times 12 minus 2x times 10 minus 2x. So there is your volume of the box in terms of x. The next question says use your calculator to find the value of x that produces the greatest volume. Okay, so the greatest volume. We already drew the picture of the box. If that's helpful, then do that. Now, we don't have to multiply all this out. All we have to do is put it in our calculator. And now, since we're not pressing sine, cosine, or tangent, the mode does not matter. So we can just go to y equals and type in x and 12 minus 2x. Close your parentheses. Now, when we graph this, again, our calculator's cleared, so it's in the negative 10 to 10 on the x and the y-axis. But we got to think about what could our possible x's be. So looking at this picture right here, we know x has to be greater than 0. Because if x is 0, there's no box. And we know that a side can't be negative, so therefore we know that x must be less than. If we plugged in a 6 right here, we get 12 minus 6, but if we plugged in a 6 over here, we get a negative, so it must be less than 5. So all we care about over here are the numbers between 0 and 5. So I'm going to put in a negative 1 and a 6, because that's all I care about on the graph. Notice that it goes really, really high, then it comes back down. So I need to go further up. I need my y max to increase. Let's say 50. That might not be enough, but let's see. Alright, still not quite high enough. Let's change that to 100. And now we can see the maximum volume. We don't care about anything to the left of the y-axis. We don't care about anything below the x-axis. Okay, because negative volumes and negative side lengths don't make sense. So all we care about is that little parabola looking thing between 0 and 5. And now we want to find that high point. So second trace 5. Nope, not second trace 5. Second trace, we want to find the maximum, so 4. And then we move our cursor over to the left of the max. Enter. Move our cursor over to the right. Those of you that have those nice fancy calculators with colors, those little lines show up. That's really nice, because then you can really tell that you're on either side of that high point. And enter. So be sure you answer the question. Find the value of x that produces the greatest volume. So that would be x equals 1.811 inches. That will produce the greatest volume. If it said what is the greatest volume would be 96.771 inches cubed. All right, now this one is just really basically, can you do things in the calculator? Okay, can you type things into the calculator correctly? All right, so there is our equation in y equals. Again, be sure you have all the x's. A lot of times I see that you forget to put an x, you forget to put a squared or a cubed, whatever that is. So be sure you have all of those things correctly put into your calculator. All right, so the first question says, what were the sales in 1995? Well, if t equals 0 represents 1990, that means 1995, that's the same as t equals 5. So we just go to our table and look where t equals 5. Second graph, we go down to 5, and there is our value. Now it's important to know what it's in. The S is in millions of dollars. So therefore our first answer would be $15,075, and that would be million. So be sure to have that million word, or put the 6 zeros after it. Either one is fine, but either have to have million or you have to have 6 more zeros. The next question, in what year are the sales to be 52,200 million? So now it's telling you y equals 52,200 million. Since the equation is in millions of dollars, we don't have to put in 52,200 million, we can just put in 52,200. So we want to know in what year or years were the sales 52200. It gave us the y value. Now remember, when we graph this, if we look at our window, our y max is at 100. This is at 52,200, so we need to be above. I'm going to go to 60,000. And now our x min and max, probably not going to work, so I'm going to change that y max to 100. Because again, we don't care about any of the negatives. So now I'm going to graph that. Alright, so I have where it goes up and down, but it didn't quite go high. Oh, but it doesn't matter how high I go, because remember, we're finding where, how long, or in what year are the sales predicted to be 52,200 million. So there's two answers right there. Notice it goes through twice. So we want to find now the intersect, so second trace 5. And you want to find both of them. There's two different times it happens. It goes on the way up and on the way down. So at x equals 9.2 years. So if t equals 0 is 1990, that means we add 9.2. So in what year, whenever it says in what year, we don't round. If it said how many years, we would round. But in what year, 1990, 91, 1992, 2010, whatever it is. So we would just add the 9. So we get 1999. And second trace 5, we need to find that other point of intersection. So again, just go get closer to it. As long as you're closer to it, doesn't matter if you're exactly on it or not. Enter, enter. If you hit enter too many times, it's going to go away. So x equals 47.29 something. So we add 47 to the 1990, and we get our second year, which is 2037. So that is when it says in what year. In what year We don't have any rounding going on. So even if it was 9.9, 9.8, 9.763, 9.1, 9.0, any of those, that would be 9 years in the 9th year. So we would add 9 to the original year. All right, if this model still applies, what would the dollar value be of computers in 2035? So 2035 means that T is equal to 45. So now we can just go back to our table, second graph. But I don't want to scroll 45 times. So I'm going to go second window, and I want to go straight to 45, so I can just hit table start 45, and now when I go back to my table, it's there. And there's my answer. So here that would be 365,475, and again, that is in millions. So we have to be sure and have that word million there, or add the 6 zeros. All right, and then the last question, in the red. Hopefully you know what that means. If you don't, here's a little lesson. You don't ever want to be in the red. That means you don't have any money. Okay, so in the red means no money left. If we have no money, that means S, or in this case Y, is equal to 0. So just like the problems we did in the last unit, when does the ball hit the ground? The height is 0. Now, S is the amount of money you have. We want to know, or the sales. So we want to know when the sales, when we have no, when we're in the red, we don't have any more money. So instead of this, when is it 52,200 million? Now we want to know, when is it 0? And I'm going to change my window back to, let's go Y max of, I don't know, we'll just go 10. And graph that. So it looks like a straight line, but it's really not, just because I changed my viewing window. So second trace, 5. We want to know when it crosses right there. Enter, enter, enter. So at 47.614. So this one does say after how many years. So when it says after how many years, we are going to round. Now notice that Y equals 2.1 E negative 8. All that means is, that's another way of the calculator saying 0. So it's just a really little number, because that decimal point would be moved to the left 8 times. So 0.0007021, you round that to the thousandth, you get 0. So in the red would be 47.614 years. Notice the difference between these two questions, how they are asked. In what year versus after how many years. All right, so very important that you know the difference between those and know when to round and when not to round. How the question is asked. It will be the same way on the homework. It'll be the same way on your test. So be sure you know how it's asked, because on the test, no one is going to help you. None of your teachers are going to tell you what it means. You are expected to know. That's part of studying and knowing how the question is asked. All right, the hypotenuse of a right triangle. So we have a right triangle here. Hypotenuse is 25. This would be a non-calculator problem. The length of one of the legs is 10 less than twice the other. So 10 less than twice the other. Use whatever letter you want. I like using X. So how do we find the length of each leg? It's a right triangle. A squared plus B squared equals C squared. So we have x squared, then I'm going to square that. I get 4x squared minus 40x plus 100. Again, this would be a non-calculator problem. So 5x squared minus 40x. You need to set that equal to 0. All it is a quadratic. Now, because we're solving, only because we're solving can we divide by 5. So we get x squared minus 8x. If we were just factoring, we wouldn't be able to do that. So x and x, you need factors of 105 that gets you 8. So a negative 15 and a plus 7, so x equals 15 and negative 7. Now think about the question we're asking. Can the length of the side be negative 7? It cannot. But it can be 15, so we have 15, and we are in meters. And 15 times 2 minus 10, 20 meters. There are the lengths of the two sides. All right, so here you got to do a little bit of thinking, going back to geometry, maybe drawing a picture. For me personally, drawing a picture is very helpful. So we have a rectangle of perimeter 90 centimeters is rolled into an open cylinder. All right, so first, let's think about that. We have this rectangle, and it's rolled up into the cylinder. Or think of it the other way, the cylinder is unrolled. So, this right here is that length right there. And our height right here is the same as this. So when you think of it that way, to me at least, it seems a lot easier to be able to do this problem. So we got to think about a few things. First of all, that perimeter is 90 centimeters. So let's call this, oh, and it does tell us that the width of the piece of paper is x. Okay, so let's call this x. And this, we can call it the length, the height. I'll call it the height. That kind of makes more sense as far as when you're looking at the cylinder. Okay? So, that green right there, think about that circle. We know that the circle is equal to 2 pi r. That's the circumference, which is the same as the length. So, x is equal to 2 pi r. You're going to need to know that also, because we're going to be comparing all these things together. All right, so if the perimeter, let's think of it as 2x plus 2h equals 90, and we want to express the volume in terms of x, that means we need to figure out what the height is in this case in terms of x. So we need the height and anything, and the perimeter of this top right here, this green, in terms of x. So, first of all, the volume is going to be the area of the base times the height. So volume is pi r squared times h. That's going to be important to know also, because what we need to do is get that r in terms of x, we need to get the h in terms of x. So that's why I said a second ago we need to solve for h over here. So 2h equals 90 minus 2x, divide by 2. H is equal to 45 minus x. So that's one thing we need. We need the height over here in terms of x. The other thing we need is the radius in terms of x. So notice that in order to know that it rolled up to a cylinder, and the length of that top of the cylinder is the perimeter of a circle. So if we undo that, it's still 2 pi r. But if we want to know r in terms of x, that means here we would need to divide by 2 pi. And we get r equals x over 2 pi. So now we have everything we need. The volume in terms of x, that means all the variables must be x. Pi, r is equal to x over 2 pi squared. H is equal to 45 minus x. So now we just need to do some math. So we have pi times x squared over 4 pi squared times 45 minus x. And now we got to do a little simplifying. So volumes in terms of x, this pi is going to cancel with one of those, so we're left with x squared over 4 pi times 45 minus x. So There is the volume of the cylinder as a function of the width of the piece of paper, which the problem told us to name that x. So without a calculator, sketch that. Well, even though this crazy looking thing, x squared over 4 pi, no matter what, that's going to be at 0. So we're going to have a 0 with a multiplicity of 2 at x equals 0. This right here is going to be x equals 0. This right here, what makes that 0? 45. We know it's a squared. We know the degree is 3 because of the squared plus the x. So squared plus x to the first, 2 plus 1 is 3. We know the leading coefficient, which is what would be in front of the x if we were to actually multiply that out, would be negative. Therefore, it goes down at the end, so we're going to have a graph that looks like this. So it's going to start up high, it's going to bounce, and then cut. So there's a sketch of your graph. So the domain of this situation. Now remember, domain is this real life situation, not of this function. If I just gave you a picture, it's of this actual picture, of this actual situation. If something was 0, it wouldn't exist. But it can go all the way up to 0. So therefore our domain would be 0. It can't be 45, because if it's 45, then the cylinder does not exist. Therefore we use parentheses, not brackets. Brackets mean the 0 and 45 are included. We cannot include them because if we include them, the cylinder does not exist. Because one of the sides is, one of the x values is 0, and we can't have that. So now find the maximum volume round to the nearest thousandth. So now you would put that equation into your calculator. All right, so you have that equation put into y equals. Now when you graph it and your calculator's cleared, you're just on your normal screen, that's what it looks like. But notice we already made a sketch of it. So we know we need to go all the way over to 45, so I'm going to change my x max to 50, and we know we're probably going to have to go pretty high, so I don't know, I'm going to make that 1500. Not 1000. See what happens. Alright, so there's our graph. Notice it does look like our sketch. So find the maximum volume. All we care about are the numbers between 0 and 45. So second trace, maximum, we hit 4. Remember, we want to be on the left side of the maximum, then the right side of the maximum, then enter. So what are we looking for? We're looking for the maximum volume. Volume equals. So if the x is 29.999, which would be 30, then we get our maximum volume. So our maximum volume would be 1074.296, and we are in centimeters cubed. Very important that you put these things into the calculator correctly.